Hello YouTube, and welcome to part 2 of overclocking your Haswell CPU. This second part of the overclocking guide focuses on the CPU ring bus. If you have not watched part 1 of the overclocking guide, it is imperative that you do so, and you need to be stable before you can proceed with any of these settings. If you have trouble finding CPU frequency stability, one suggestion I can make is perhaps dropping the CPU ring bus down to a multiplier of 30 or 3000 megahertz and try to find CPU stability, even with a ring bus set for the default voltage as well. It's very important that your CPU is stable. Hopefully you're at the 4.4 gigahertz that we're basing this guide off of, and that's what you're going to need in order to continue. So the first thing when it comes to CPU ring bus stability is our primary goal is to reach a 1-to-1 ratio with the CPU. So if our CPU is clocked at 4.4 gigahertz, our goal is to bring our CPU ring bus ratio up to 4.4 gigahertz as well. Now, I prefer to refer to the ring bus as in megahertz. So in most cases, I will refer to it such as 4400 megahertz instead of 4.4 gigahertz. Keep in mind, not all CPUs can achieve a 1-to-1 ratio while overclocking, so even if you can get your CPU stable at 4.4 gigahertz, there's no guarantee that you're going to be able to run the CPU ring bus at 4400 megahertz. Finding ring bus stability is extremely time consuming. The settings are very small, and you're moving in small increments and trying to test. This takes a long time. I know from personal experience. I'm going to give you some of the best settings that I can recommend. However, really this comes down to your individual CPU, how it's communicating with your board, and there's so many variables that I cannot control, even though I'm doing my best to control what we can. So this is a very time-consuming process, and it's taken me a long time to make any headway with the CPU ring bus while looking for an aggressive CPU overclock and finding stability. So basically what I'm going to have you guys do is we're going to set our CPU ring bus multiplier at a 1-to-1 ratio. I know that I'm stable at 4.4 gigahertz at a voltage of 1.23 volts. Your results may vary. I've seen as high as 1.28 volts for 4.4 gigahertz, but I now know that my CPU is stable for 1.23 volts. So in order to maintain a 1-to-1 ratio with our 4.4 gigahertz overclock, we're going to first set our processor input voltage indicated by the VCCIN voltage. We're going to go ahead and set that for 1.9 volts. We're also going to set our CPU ring voltage to whatever core voltage we found stability with for 8 hours using the Intel Extreme Tuning utility. For example, if you were able to find 8 hours of stability at 4.4 gigahertz with 1.28 volts, you are now going to set your CPU ring voltage for 1.28 volts. So in theory, we're kind of keeping that at a 1-to-1 ratio as well. And then we will begin to decrease that voltage as we go. One thing I'll recommend is basically do not allow your ring bus voltage to exceed your V-core voltage. Sorry for the typo there. It's imperative to remember that there's really no large benefits from maintaining a 1-to-1 ratio. If you've got to kick it back 1 or 200 megahertz, that's better than having to exceed the voltage to find stability. I personally have not exceeded my core voltage on the ring bus voltage to look for stability. However, it's one thing I might consider trying while I'm looking for my 1-to-1 ratio at 4.6 gigahertz, which I have not found yet. So once again, try to keep your V-core voltage at a 1-to-1 ratio with your CPU to begin, and after you find CPU ring bus stability, then we can start bringing down that CPU ring voltage as well. So basically we're going to input these settings, and then we're going to boot up our system, and we're going to stress test. Once again, very, very important, we need to maintain a minimum of 8 hours stable before we can proceed. Okay, 8 hours is the absolute minimum requirement for any type of system overclocking validation, in my opinion. Okay, so we need to keep 8 hours stable. So if you're able to boot up and stress test for 8 hours at the settings I recommended, with the processor input voltage at 1.9 volts and keeping your CPU ring voltage at a 1-to-1 ratio, that's awesome. What you can start doing now is reducing the voltages. So I don't believe you're going to get much less than 1.9 volts. You may as well set your VCCIN voltage to default, because the default on most boards is 1.88 volts. So you can try to drop it from 1.9 to 1.88. Chances are, though, you're not going to find any type of stability at 1.88 and a 1-to-1 ratio. But you can give it a shot. You always want to try to drop the voltages as low as you can go while maintaining stability for 8 hours. This part of the process is very time consuming, because you find a stable voltage and then you start dropping it. Sometimes you might just drop it pretty low to see how it's stable, maybe meet in the middle and find some stability in the middle ground, right? It's entirely up to you on how you want to do this, but we do always want to reduce our voltages to as low as possible while maintaining stability for a minimum of 8 hours. Also, if you're stable, you can start reducing your CPU ring bus voltage as well. For example, if you were able to get your CPU stable at 1.28 volts for 4.4 gigahertz, you brought your CPU ring bus up to 4400 megahertz and got that stable at 1.28 volts as well, you can start dropping that off until the system becomes unstable. Typically it might be 1.26 volts, 1.24 volts. It's really hard to say. Just start dropping it until the system becomes unstable and you cannot complete your stress test for a minimum of 8 hours. Once again, this is very time consuming. I've taken the time to do it, and if you want to maximize your performance per watt ratio on your overclock, you're going to have to take the time to basically figure out how your CPU ring bus voltage is going to work. Now, if you have not found any stability so far, what you need to start doing is you need to start increasing your processor input voltage, which is your VCCIN voltage. I recommend start increasing the voltage in 0.01 increments. So because we're starting at 1.9, your next increment would be 1.901, and then 1.902, so on and so forth, as you can see, and you're going to move up all the way to 2.1 volts. I don't believe for a 4.4 gigahertz overclock any more than 2 to 2.1 is not going to help you whatsoever. You'll be dropping your ring bus ratio before you find stability in that voltage range. So if you cannot boot up and stress test, basically leave your CPU ring voltage at the 1-to-1 ratio and keep your VCCIN voltage, start increasing that until you can find stability. Okay, now if you get all the way from 1.9 to 2.1 volts and you still have not found any stability at a 1-to-1 ratio, what you are going to have to do is start dropping your CPU ring multiplier. So for example, we are at 4.4 gigahertz and our CPU ring multiplier is also at 44. So we're going to drop that down to 43. And we're going to actually change our VCC-IN voltage, or processor input voltage, to 2 volts. Now that's going to keep the processor input voltage somewhat high, but it's not too high that I'm concerned you're going to do any type of damage for a 4.4 gigahertz overclock. Keep in mind the fully integrated voltage regulator on the Haswell CPU will require up to about 2 volts to operate properly. So that's why we're going to input that voltage, even though most default parameters from motherboard manufacturers is about 1.888 volts. Okay, so if you cannot find stability doing what we've talked about, set the processor input voltage for 2 volts and start reducing the CPU ring bus until you find stability. A fine example of that would be you're stable at 4.4 gigahertz, but you are only able to maintain a 4200 megahertz ring bus. And I've seen this from more than one user on the Linus Tech Tip forums that I try my best to help out on. I've seen a user find this type of stability at 4.4 gigahertz with only a 4200 megahertz ring bus. Now, after you find the best possible ring bus frequency and you know that you're stable for 8 hours, start reducing the voltages once again, like I talked about earlier. Start bringing down the processor input voltage, the VCC-IN, and get stable. Bring it as low as you can go until you're stable for 8 hours. Do the same thing for the CPU ring voltage. Bring that down as low as you can until you're stable for 8 hours. Here's a couple examples of processor and ring bus stability I have been able to achieve through my own testing. My 4.4 gigahertz overclock, I was able to get 20 hours stable at 1.23 volts. I was also stable on the CPU ring bus at a 1-to-1 ratio at 1.22 volts. These are the lowest possible voltages I could go as well. And then the processor input voltage, or VCC-IN, was at 1.9 volts. For 4.6 gigahertz, I am still not able to maintain a 1-to-1 ratio. I had to drop my ring bus down to 4500 megahertz. It's fairly close. So my processor was stable at 1.35 volts. My ring bus was at 4500 megahertz, and I was able to drop the ring bus voltage down as low as 1.3 volts. Any lower and it was no longer stable for a minimum of 8 hours. And then my processor input voltage once again was 1.9 volts. Now, to give you an idea of what I'm working on right now, is I'm trying to find stability at 4.6 gigahertz with a 1-to-1 ratio. My CPU is also stable at 4.7 gigahertz, but I'm going to work on 4.6 and then I'm going to work on 4.7 next. So to give you an idea of my results so far, I've been able to keep my CPU at 1.35 volts. Sorry, this is a little backwards. So my CPU is at 1.35 volts. My CPU ring bus is actually at 1.3 volts. And the processor input voltage right now is 2.04 volts. The maximum amount of stability I've found at this setting so far is 9 hours. It crashed after 9 hours of being stable. I'm currently running it at this settings, and I've been able to render videos and play games. So what I'm going to do next is basically shut the computer down, and we're going to go into the BIOS once again, and we're going to set these values as I described, so you have an idea of what to do with finding stability in the ring bus. Okay guys, now we've booted back into the BIOS. We've found stability at 4.4 gigahertz. So we're going to start working on our CPU ring bus now. So the first thing that we are going to do is we are going to adjust our CPU ring ratio. And I'm going to set that for 44, keeping a 1-to-1 ratio with the CPU. The next thing I'm going to do is I'm going to change the processor input voltage, or VCCIN voltage. I can see my stock value is 1.792, and I'm going to be changing that voltage 1.9 volts. The next thing I'm going to do is change my CPU ring voltage. Now I have found stability with the CPU core voltage of 1.23 volts. So what I would suggest is when you start, you input 1.23 volts. Now don't be alarmed, this is nothing crazy even though it's indicated in red. 1.23 volts for a ring voltage is very, very stable. Now the next thing that you want to do is basically save your, hit F10, save the configuration, and restart. Now once again, okay, so we've rebooted now, and we are about to start the Intel Extreme Tuning utility again. Once again, I'll be going to stress test the system. I'm going to start for 2 days, and go ahead and start stress testing. Please forgive the camera. Now there you go, we're back stress testing again. CPU's at 100% load, 4.4 gigahertz, and once again our voltage, I set it for 1.23, getting a little bit of V droop there. Like I said in my previous video, plus or minus 0.02 volts on the CPU core. Do not worry about it whatsoever. And my CPU core temp is very, very, very good for 4.4 gigahertz. Now I'm going to show you our I can't really capture it here. Okay, so if you look, our processor cache ratio is now set at 44, so we've confirmed that it's at a 1-to-1 ratio. I can also see that my processor cache voltage is at 1.23 volts. So that's how to confirm that the settings that we changed are accurate. And once again, you need to get stable. You need to be able to run this test for a minimum of 8 hours. If you cannot get stable at 8 hours, you're going to start increasing your processor input voltage until you find stability. If that does not help at all, you start reducing your CPU cache ratio, or the CPU ring bus. Start bringing that down from 44 to 43 to 42, 41, whatever it takes to find stability. Last thing you do, once again, is you're going to reduce all of your voltages as low as you go, while maintaining stability for a minimum of 8 hours. Keep that in mind. It is very, very important. You need to be stable for 8 hours. So there you go. Another way to ensure that your cache ratio is at the desired frequency is to bring up CPU-Z, and the cache ratio in CPU-Z is indicated under the memory tab as the North Bridge frequency. So that's another way to verify that the processor cache ratio is running at what you have set it to run at. And if you look, once again, my RAM is still clocked to 1333, even though it runs much faster than that. I've eliminated that as being an unstable variable. The next video that we're going to do talks about bringing our memory back up and finding stability with the memory after we validated our CPU frequency for 8 hours, our CPU ring bus for 8 hours, and then we are going to start stress testing our memory and get that stable for 8 hours as well before we can go ahead and call our overclock actually validated and stable. And the last thing we will do is work on the power saving functions of your Haswell CPU to make sure that the voltage is kicking down when it's supposed to, and so is the frequency, and so you can enjoy those low power states that that the Haswell has been fairly known for, and it's one of the major benefits of going to this platform, right? So that's in the last guide that I published. Hope you've enjoyed this. Please comment, like this video, and check out the links in the description below for part 1 and my system overview, and hopefully the memory overview, as well as the enabling the Haswell low power states. Thanks. Bye.